All right, number 3, we want to indicate which of the 4 graphs is the correct graph for log base 3 and x minus 5. Okay, so let's go back to content. So here is the graphic of what log looks like. So this is when b is greater than 3. So it's going to curve upward and go through the ordered pair 1, 0. So if I use that, the general shape of log, notice in parentheses with x we have a minus 5. So when we talked about transformations, it does the opposite of what we think. So a minus 5 you would think goes left 5, but it's actually going to move this graph to the right 5, and that's the only transformation we have. So since this base is bigger than 3, it's going to curve upward like it is showing, so that one is out for sure. And all we're going to do is take this ordered pair 1, 0 and go 5 spaces to the right. So 1, 2, 3, 4, 5. Looks like I should be over one more. So let's take this one. 1, 2, 3, 4, 5. So it looks like this graph is the one that's going to cross in the right spot. So this, all I'm doing is using properties of transformations and applying it to what we know about the general log graph. And of course you can graph this and get an image on a calculator. It might look a little bit different because of the window, but let me also show you that one. So I'm going to turn this on, go to y equal, clear out anything I have, and then I'm going to do, so I don't know, I guess actually I do know, if you have the older version of the calculator, which is the TI-83, you will not be able to change the base, but I think there is a way that we can do that. But when you have a base 3, notice if you hit this log button, it doesn't give you the option to change the base. It's understood to be a 10 and it's keeping it that way. So I'll show you how to get around that. But if I want to change the base, I have to do alpha and then the y equal button, and then you get some drop down menus. We want to go to function because log is a function, so just hit the window button and then you get this, and then option number 5 says log base. So I'm going to go down to 5 or just enter 5, and now it's giving me the option to change that. So I can do log base 3 and then I can do x minus 5. And then when I hit graph, okay, it just kind of shows a little piece of it curving, and then I think you should be able to tell from that this one is the correct one. Also, let me turn this graph off. So I'm going to hit enter where that cursor is on the equal sign. That will turn it off. So now if I hit graph, it takes it off. It's not showing anything. So I'm going to show you the way to do this if you couldn't change the base in the calculator. So there is one thing that is called a change of base formula, which you'll see that sometime later for sure. Change of base. So what you do, if you have something like this, log base b, and then you're evaluating at a, okay, what you do is you take log base 10 of a on top, and then you do log base 10, and then you do whatever your base was, b on bottom. So you just, the big number on top, the base on bottom, and then that will do the same thing. So let me do that real quick just to show you get the same thing. So in our case, I would do log of x minus 5 on top. That's what's in the position of a. And then I would do log of 3 on bottom. So log x minus 5, and then sorry, just gotta go back up, divided by log, and this would be 3 on the bottom. And then if I graph this, okay, we get that same image that we just saw a while ago. So you can do it with calculator as well, but it's better if you remember transformations. Okay, so this one is less than 1. So whenever the base, so let me give you a general shape. Log, let's just say base 2 of x. If you have this graph, it's going to cross at 1, 0. And it's going to be curving up like this. That's going to be the general shape of that graph. Now also, if you have log of something less than 1, a half, so it should be doing almost something similar, crossing at 1, 0, but it's coming from the top down. Okay, it just kind of gets flipped across this x-axis. And so this is the difference. So with this 1/2, I know that my graph is coming down and curving this way. This +2 is outside the parentheses, so it's not going to be a horizontal shift, it's going to be a vertical shift. So this graph is going to get shifted up 2 units. It's going to be curving down and get shifted up 2 units. So I'm imagining it's going to cross at 1, 2. X is 1, Y is 2. So the one that looks like it's crossing at 2 right here is this guy. Because it got shifted up, it's crossing at just 2 spots above where we started. So this is the graph that we're going to be looking for. And again, it's best to just graph these based on transformations. You might have to go back and review transformations.